most part, you guys were good on this one. So increasing from 2 to 6. So 2 to 6 is this little curve here, okay? It is only increasing from 2 to 4, not from 4 to 6. So this one's false. And again, most of you got that right. Questions on that one? Okay. Then the next one said it's concave down from 0 to 2. From 0 to 2 is this part here, okay? That is part of your U shape, which means it's concave up, not concave down. So this is also false. This bigger. Okay, then G is concave up on negative 6 to 2. So for to negative 2. Negative 6 to negative 2 makes that full U. The whole thing is in that U, which means this is true. 4, it decreases and is concave up. Okay, so let's talk about the difference between decreases and concavity, okay? If I just looked at this little section here, right? If I look at this section here, there is part of this. What is that, concave up or concave down? Concave down. It's concave down the whole way, right? But part of this is going up. So from here to here would be increasing and concave up. And then this part is coming back down, which means it's decreasing and concave up. Does that make sense? Concave down, concave down. Jeez Louise. Both of them. We just said that, right? Down and down. Does that make sense? So your concavity does not necessarily mean increasing or decreasing. Something that is concave down can be increasing or decreasing, and something that is concave up can be increasing or decreasing. Concavity is talking about the rate. So if it says it's at a decreasing rate, that means concave down. Increasing rate, concave up. Increasing, decreasing, not the same thing, okay? So in this section, this is all what? Concave up. From negative 6 to negative 4 is decreasing. This is still up. And then from negative 4 to negative 2 is increasing, but concave up. Does that make sense? Yes? Okay, Rodrigo.
If it said from like negative 6 to negative 2 and it said concave up, but it said like either increasing or decreasing,
it would be it has to, both of them have to be true, which is what happened with 6. So G says it is concave up from negative 2 to 0. And we said that this is true, right? It's part of our U. This one is, wait, did I just read the wrong thing? G says it's decreasing and concave up. It is decreasing and it is also concave up, so it's true. G has zeros at positive and negative 2, positive and negative 6. Everybody got that right? That's true, okay? And then this is the one that got you, which hopefully after that last explanation makes a little bit more sense. G decreases on a decreasing rate. So decreasing rate means concave down. So this is saying it is decreasing and concave down from negative 6 to negative 4. It is decreasing, but it is not concave down. Does that make sense? Yes? So that's false. What was the hand? Did I answer it? Yeah.
Can you explain like rate of change?
Like in general? Like the whole section tomorrow.
Okay.
Yeah, tomorrow's section is titled Rate of Change. And then Wednesday or Thursday section is titled Rate of Change for Linear and Quadratics. So it's going to get shoved down your throat soon enough, my friend. But rate of change is easily described as slope. But if we wanted to pick and do slopes on all these little sections of like a pick a point and draw a slope and pick a point and draw a slope of, they call it a secant line. And I compare those slopes. That's the other way to test for concavity. If my slope is increasing, then it's concave up. If my slope is decreasing, then it's concave down. That's really what rate of change and concavity meet together. We're going to do a little bit more with it tomorrow because I think the visual is a little bit easier. Yeah.
What's the test?
The test is not for like 2 weeks. The quiz is Friday. Yeah.
if we had like from like points 1 to 3, but let's say like that curve was smoother, so we couldn't really tell, how would we know what concave it would be?
From 1 to 3?
Yeah.
Oh, you mean like if it was, it would have to literally be an extension like that.
Okay.
I'd have to be able to continue on with my curve. Yeah. You're welcome. Okay, so then these we got better. When is the graph concave up? It is concave up from 0 to 2. This section to this section is concave up. When is it concave down? From -2 to 0. The zeros of the function, remember we list these, -2, 0, and 2. The y-intercept, y equals 0. It is increasing. Now this is where it comes in parts because it is increasing from here to here and from here to here. So my increasing is from -2 to -1 and from 1 to 2. And then it is decreasing from here to here from -1 to +1. Yep.
If it were like a normal line and not a segment for the first part, could you put the X on the other side of the one and make it still the same?
What?
Like does it
Sorry,
matter
let me
order?
speak. All right, this one was a little bit harder around the 2, 3 range. So the concave up was in here, and I would say if you were really precise, it would have started here and it would have come up here. And then concave down would have started there. So some of you were close, and again, like I would probably not put something that's that hard to see on a quiz or test, but technically there's a change there. And again, if we wanted to be really specific, we could start talking about the slopes of that line, but we'll worry about that in a little bit, okay? So my concave up is really from 1 to like a 2.5. My concave down goes -2 to 1. And then again from 2.5 to 5. The zeros of the function are at -1, 1, and 3. The y-intercept is at 1. It is increasing from -2 to 0. So here and here from 2 to 0. No, to 3, sorry. And then it is decreasing from 0 to 2 and from 3 to 5. Yep.
You wouldn't have it be like that close.
Probably not that close. Like you'd have to, because I was able to zoom in and look at that. You're not able to do that on a piece of paper. Yeah,
Let's say there was an arrow at the end, it would have just been x is greater than 3.
correct. All right, then this one, the paper airplane is thrown out of the classroom, the second floor, whatever. I'm going to model it, right? The paper airplane comes up and it comes back down again. The full graph does this, but it really starts its origination point at the y-intercept, which is where it's thrown from the window, 14.5 feet. Okay, or meters. And yesterday I did that too. I think we did it in feet and it should have been meters. The maximum height reached is this point here. What's that K again? What was your K? The highest, is it 14.75? Okay. We changed this because T is in terms of time. So how long does it take to hit the ground? And the visual representation of that is the X value at your 0, right? Which was what, I just erased it, 8.68, is that what it was? Okay. And it's in seconds. Okay, these are the AP questions, right? Or from AP Classroom. So the first one was your rate of change. And again, the wording is important here because now we're talking about rate of change. So when we say increasing rate of change, we don't mean my graph is just going up, okay? That's just increasing. And increasing rate of change means it's what? Concave up. And a decreasing rate of change means concave down. So when it asks the table, blah, 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 which of the following intervals of the graph concave down, I'm looking from 2 to 3. This was 2, and this is the one I said it was kind of beneficial to show, like on that second video, she shows an animation. Whereas the car is going around this circle, it's starting at a point, it's going away from you, it's coming back to you, it's going away from you, it's coming back to you, and it takes on that curve, which never goes past you. It never comes back past this starting point, okay? Which is why you would rule this out. It doesn't always increasingly get further away from you, which is why it would increase that one. And it has a gradual circular motion, okay? What other thing has a circular motion that we put on a graph like that? Sine and cosine, yes? Yes. Unit circle, sine, look, it takes on the same shape, okay? Which, don't worry, if you missed it, it's coming back, okay? That's definitely on your test. But just think about it, kind of takes on that shape. 3 was this one. It said graph the function, or the graph of the functions given. Follow which of the following statements about the rate of change from 2 to 6, okay? Where it's greater than 2 but less than 6, okay? That takes on which shape? Concave down, which means rate of change is decreasing. 4, this was your graphing calculator one, which I should have graphed, but I think it was this one, right? It said you had the shape, ball's thrown through the window, okay? The height of the ball increases to maximum. This was 16.228. And then it says the height of the ball decreases until it reaches the ground 1.820 seconds after reaching the maximum height. So this was the distance you had to find. You had to find the x value at the maximum, and then you had to find the 0, and then you had to subtract the 2 to get that distance, okay? Questions on that one? Okay, then the second question, oh wait, no, 5. Back to rate of change, okay? So it says the table gives the characteristic of the function on the intervals. Which of the following is true about the interval? Oh my gosh, I cut off the picture. Does it say 3 to 4? Yeah. 3 to 4, which is here. Positive and decreasing. So decreasing already tells you rule out this one, right? Because it needs to be concave down. And then if it's positive, it is increasing. So that's your A. Okay, and then the vase, which drove you guys crazy, which is kind of funny. All right, so we want to fill this vase, and we want something that is growing, what's the exact wording? Clearly concave up, and the next portion of the graph is fairly steady and steep increase. So concave up means it's increasing, right? If I'm pouring something into a bucket and it's getting bigger at the top, it's filling slower. So my rate of change would be decreasing, which means I needed something that was coming in, okay? I needed something that was coming in the whole time, which is really B. It's the only shape that does that, okay? It started steady, and then it grew into a steep increase, which is why that top gets smaller at the top, or that's why it gets smaller at the top. Questions? Yes, you're going to have to be able to connect random stuff like vase filling with your increasing and decreasing, okay? There's not a lot of that stuff, but it is going to happen, so get used to it, okay? All right. This, we went over it right, well, I posted this. Any questions on the PDF part?
That's on Canvas.
This is on, yeah, I added it to the assignment. Yeah.
I put J, so like how do you know like where to stop?
So hard sometimes to, like, I like visualize it changing there. It changes, like it's passing. Tomorrow, we're going to talk about rate of change, and you literally could find the slope. It's called the slope of a secant line there. And if the slope of those lines is decreasing, then it's concave down. And if the slope of those lines is increasing, then it's concave up. So it might be easier on some of those things to kind of visualize those lines. But to be honest, like, I don't foresee them getting something that's that close together. Yeah. Any other questions? Okay.